Good morning, everyone. My name is Leandro. I work at Blinkist. And today I'm going to talk about two databases, two libraries that was developed by Square that will help you work with your SQL queries. But before I start, I'm going to go through the outline so we can see what's going to come. So first I'm going to talk about SQLite in the context of Android, and then go through the pros and cons of that, and then try to see what is there that tries to compete with SQLite and tries to alleviate the problems of SQLite. Then I'm going to go through a deep dive of each of those libraries, and then finally see how they work together. And last, I will just briefly mention Room a little bit, because some people ask about it, so it's nice to have a little bit of comparison here. And then finally, we'll go and review everything that we learned. Cool. So let's start SQLite, or in the context of Android. So why SQLite such a big thing in Android? Well, first is because it came from the Since API level 1. It's the standard. It's the best implementation of SQL that fits the mobile device with like very little resources. And it's also used by the majority of the native pre-installed apps, like the contacts. Also, it's very powerful, and it covers an incredible amount of use cases. And it does so because SQL is very powerful and very flexible. It's also efficient, and the efficiency, it's because SQLite is obviously like a very efficient language, but also because the way SQLite was added in Android is because there's just a very thin interface that wraps the bundle SQLite in Android. So every call is very quickly delegated to the SQLite itself. That also means fast, usually faster than other alternatives, especially when you work with lots of data. And also stable. The version that Android ships is SQLite 3, and SQLite 3 was like released in 2004, and up to this day, 13 years later, all databases that you created with SQLite, it's still readable by the current version. So there is no breaking changes since 13 years ago. Finally, it's also cross-platform. So you can, everything that you do with SQLite, you can also, since because it's like a file on disk, it's a single file, you can just move to other architectures and make use of that. But nothing is all good, so there's also some cons in there. And in particularly for Android, it's hard because we all been here, right? So we have to deal with cursors. And even though SQLite's easy to learn, like in order for you to master cursors, like it takes, a long time. At least for me, it was very, very hard. It's also super verbose. Like, I'm going to go through some examples, but the API is not so good. Another problem, I think for me is the biggest one, is that there is no type safety. So everything that you code, everything that you write there, the consequences of it will only see on runtime. But this is too late. It shouldn't work like that. Yeah, so that's how it's implemented, like as the top of the native bundle. So just some example, this is like from the developer.android.com. I don't want you to read all of that, but I just want to point out some parts of it, particularly this one. So what is bad here? So we have, first of all those string concatenations, and that is the first waste of resources because you end up creating a lot of objects. And you have to make sure that you don't do things like, for example, miss this space over here, because if you do so, then you're querying for a column that doesn't exist, and you're not passing the proper sort order. So again, it's going to crash on runtime. But it's not the worst. So there's also more things, how you properly get your data from there. And this is for me also, I think, like the worst. Because you have to, for every single column that you're querying, you have to know the index of it. And not only that, but then you have to extract as a correct type. So you know that for the ID it has to be a long, for the title has to be a string, and sometimes you can get messed up, and again, it won't go away. Finally, you also have to close the cursor. Some people forget about that. It's really important not to. So no one wants that. It's really, really bad. So let's not go through this way. Because of all those problems, people thought there has to be a better way to do that. And over the years, many libraries tried to implement something that did remove this pain from us. And one that's very relevant for Android is like the Object-Relational Mappers. And basically what it does is It's a technique for converting primitive data types that SQLite holds to your incompatible types that you define on your Java or your object-oriented language. So basically, it converts between these primitives to this, it does by wrapping the SQL source that you provide, and sometimes this wrap can be very thick, and the consequence of that is that the performance gets decreased. Some examples, some libraries that does that, it's like GreenDAO, ORMLite, Cupboard, or on the iOS side is also Core Data. But it's also not so good. You have to learn new APIs, and well, you can argue that you also have to learn SQLDelight and SQLBrite, but hopefully at the end of this talk, I'm going to show you to you that what SQLite and Delight does is very minimal, and you won't go through the pain of learning it because everything's kind of automated. So there's an asterisk in there. Also, it hides many powerful SQL capabilities. And it does so because it doesn't really know what you're going to use from that. So all the complexities gets hidden, so you can use like as a nice way to, if you need, for example, to query a list of foo, then it's fine. But once you have to fine-tune your query, then those libraries know better than you do how to properly query that in an efficient manner. That also causes decreased performance. Well, this is also an asterisk because Realm, for example, is a library that tries to focus on performance pretty much. But like in general, like this usually causes like a performance issue. Because it's also tried to be helpful and friendly and approachable, it really doesn't allow you to customize it in the way that you want. Sometimes it can be it's easy to put in your project, but it's very hard to make it work for you. One point that I also want to mention is that the objects that they use is like usually mutable. And when you're querying your database or inserting data in your database, you're doing a background thread. And since you're handling different threads, immutability is something that's very nice to have. And finally, it's a lock-in effect, because once you start using those libraries, you try the code that those libraries spread throughout your code base, and it's very hard to replace later. And also, this is a phrase that Jake Wharton told once, like SQL is very powerful, and it should not be hidden, it should be embraced, because it is very powerful, and it's something that we all gain from learning using SQL. So they solved these problems, like the scenario was not so good. So a couple years ago, they decided to, I think Jake Wharton mentioned that he wrote like 16 implementations of databases to database helpers that would alleviate those needs. And I think a couple years ago that they sat down those two libraries, mostly Jake Wharton, Alex Strong, and some other brilliant people from the community. The first one I'm going to talk to today is SQLDelight. So what does SQLDelight do for you? So it empowers, as I said, it empowers SQL, embraces it, and it does so in a type-safe manner. It provides you type-safe APIs, so you can read and write, you can marshal and unmarshal your data in a safe way. Also organizes your statements into files that is easy to manage and organize, and it is also easy to access from Java. How does it work? Well, everything that SQLDelight does, it does at work compile time. And its purpose is to create those Java classes that makes your operations type safe. Yeah, everything does based on how you define your create table statements. And you do that on special files that contains all SQL that you're going to mention. And the extension that you're going to use is that SQ. As I mentioned, it does also compile time. So how do you make use of that? So in your build script file, you just add those dependencies, and also don't forget the plugin. And not only that, but they also provide an IntelliJ plugin, and the IntelliJ plugin can be found there. It provides so many nice features. I'm going to go through all of them now. It provides syntax highlighting, and it also helps you refactor and find code. It also does code autocompletion, and it generates the models after you edit them. So you don't have to recompile. Everything happens as you type. And you also have nice features, like, for example, if you have a very complex SQL, you can right-click and copy as a valid SQLite file or statement. And as you write, it validates what you write, so nothing will get compiled if the types doesn't really match. And to show you that, I have recorded a little video. So I have a simple query here, and this is from refactoring one select. So you can see that I'm trying to write down like a custom version of a name, and it auto-completes everything. And as I create a new projection, it highlights what is wrong. And so if I don't fix that, the project won't compile. So it's very type safe. This is how you experience it. One thing to keep in mind that for it to work is that the file structure of your project has to be in this one particular matter. So the SQL files, excuse me, the SQL files have to be in a folder that matches the directory structure. And one example that I'm going to show you here. So let's say you have this application with this particular package, and you have, for example, this book.java class. So your files.sql has to be matching that. So exactly the same, you have a folder that's called SQLDelight, is a sibling of the Java folder, and you're going to put your SQL files there. And that's basically all that SQLDelight asks you to do. Let's take a look at one .sql file. So here I have a simple example. It's just a simple table, book, have 4 fields, some not null. But this is like the top part of your SQL file. Down there, you should also put your statements, some selects, some inserts. Everything goes through on this file, so it's easy to read, it's easy to manage, it's easy to see the highlights. I just want to point out here that SQLDelight is not only good for creating your tables, but also when you evolve it, because as you rename fields, as you move, as you do your migrations, everything will be here, and everything is going to be smoother because the type safe is going to help you there. The plugin is going to help you there. So just after writing those very simple statements here, SQLDelight is going to generate some Java model for you. And this is just for curiosity. I'm going to show you here. So it generates this interface. It's your class model, suffixed by model. And you can see here that how it does. It creates some fields. It also exposes the fields of the columns of your table exactly as you define on SQL. So you define something as nullable or not null, it will annotate correctly. That's very nice. But not only that, on these ellipses here, we'll have code that will do all the mapping back and forth. You remember that I showed you how complicated it was to go through everything. So this is the generated code. This is the most optimal way, and this is very performant. Everything is going to be type safe, and you'll see that it's going to move, it's going to go from the cursor to the model itself. Having all those generated code, how do you make use of that? That's easy. You create your book.java class in this particular example, and you extend from it. SQLDelight kind of pushes you to use auto-value, and I don't want to take much time explaining why you should use it. Obviously, it will bring you immutability, but also you remove a lot of pain point, because then you don't have to expose all the fields again, and everything goes pretty well if you just use auto-value. And also, one thing that to keep in mind is, like Android, we all have this 65K methods. Because all the fields are immutable, they could also at some point remove all the getters from the fields and just expose as final. And that saves a lot of method counts. Another thing that you also have to do is create a reference for this factory. And factory is very important. It's part of the magic that SQLDelight does. It's through it that you can get all your query statements. And it is the class that knows how to construct your model. So you can see that you pass and implement a method that knows how to create this book class. Here I'm just passing the auto-value constructor. And then using the factory, I can get this select all mapper that I defined a few slides ago. And then I have a row mapper. And we're going to use this row mapper to create instances of the book class if all the projections that you're querying is exactly what the book means, you're going to use this row mapper. OK, that defined, that's mostly what you have to do, actually. how you consume it. So let's imagine that we have a repository that you're going to query some books. So it's going to provide you this SQLite database from Android. So here you can see that I'm getting a reference from the factory and then from the select all method. And this is exposed as a SQLDelight statement. And what it is a precompiled statement that will create the structure of the query or insert or any other operation actually. And then you're going to pass what you're trying to query or insert as a string format. And it's going to replace all these %s and %d. And it will do so in a very type-safe manner. So you can reuse all this SQLDelight statement. Then you can use the standard raw query method from the SQLite database. And the query will have already the statement for you and also the arguments. So you just pass it there, and everything's going to go right. But the most brilliant part, at least for me, is that you don't have to go through back and forth with the cursor again. Everything will happen when you pass this row mapper and you give the cursor to it. So now, just with this method, you're going to get an instance of the book, and you can see that I'm already adding to this list and returning it. Everything happens automatically or magically, let's say. But SQLDelight is more powerful than that. They embrace it, the SQLite, and so it also provides features like, for example, projections and joins. And just like the book model that you saw, for every different projection or for every different join that you do, the SQLDelight is going to generate you code that will provide you an interface that you have to extend, and then a mapper to go back and forth from marshalling and unmarshalling. And then a method also, the factor that we'll use to create your class. Also provides some nice features, types. So it's going to use the same structure as SQLite, but it's going to add you a column that's the constraint, this Java constraint. So you know that in SQLite we have a few different primitive types, that being integer, real, text, blob. But SQLDelight is going to allows you to add this as something, and this something you will give you a Java class, and then by defining it so, you're going to retrieve that code as the correct type that you define. Also, we all went through the pain of storing booleans as integers, and you all have to go back and forth getting, if it's 0, then it's false, if it's 1, it's true. It doesn't have to work like that. So it just casts as boolean, and it's going to do all the work for me. But how does it work with custom classes? Well, the same way. In this example, I have this book table, and I have a field that's when the book was published, and I save as a date time. And the only thing that I have to do is give this import in the top of the SQL file, and then provide a column adapter that will know how to go back and forth from the serialized version to the deserialized version. It is pretty similar to how retrofit works, so there is no really magic here. For enums, actually, they have a built-in column adapter, so you don't have to think too much. If you have in my case, if I had enum that defined the genre of the book, for example, I don't know, romance and thriller, then I just need to provide the built-in column adapter, giving the num, and then it's going to go back and forth to this enum value. Very convenient. SQLDelight also supports table views, and table views is not something that people usually use, but if you have a very complicated table with lots of columns, and you want to have a very simple version of it. So views basically is like a pre-saved query that it's kind of like a virtual table, and you're going to query just that. You're going to expose less fields. You're going to simplify it for your consumers, and it behaves the same way. So you just define a view in your SQL file, and you just query that. Very simple. One thing that I also want to explain is that people ask me, like, does it work with Kotlin? Because there's a lot of things going on, and it might not do so. But actually, it works. Well, it mostly works. You just have to redundantly declare the getters. And I have an example here. I have, again, the book class. And so you can see here that I define my properties just like I do on the SQL file. So for example, the title is still not null here. And on the Kotlin code, everything matches exactly. So you have a question mark on the author. And the only thing that you have to do, actually is to redundantly declare everything like this. But after you do so, everything works fine. So for migrations, actually, unfortunately, it's the least supported part yet. They have been planning how to properly implement this in a good way, because the library has a huge potential to do everything for you. Because it knows so much of your data structure, it can even do migrations for you. And there is an issue on GitHub issue that Jake Wharton has been talking about implementing this as a specific files, because technically speaking, the .sql is binded to a table, so it doesn't really make a lot of sense to put your migration statements there. So they're thinking about creating this new special SQLM file, but it's still like just planning. So the current solution today that I have to suggest is to write your strings on the proper SQL open helper. I do have a little hack here, and what I do, I created this migration.sq file, and I give a just very dummy create table statement. And then I write all the migrations down there, or I can have one migration per SQL file. And the nice thing is that you can still use refactoring, and you can still, everything still gets consolidated into this directory, this SQLite directory. So don't spread code too much into your SQLite open helper. The only downside of that is that because it's, again, an SQL file, SQLDelight is going to generate you code, and you'll end up having a little bit of verbose there. You can actually prog-wire those and remove, but that's beyond the scope of this topic. So that was SQLDelight, so let's go for SQLBrite. So what is SQLBrite? It's just a very thin wrapper on SQL Open Helper that gives you reactive semantics. So, but actually not only SQL Open Helper, but also works on content resolver. And it will give you RxJava semantics, RxJava 1 and RxJava 2, recently published. And as long as you remain subscribed to those queries, every change that's going to happen in the table, you'll get notified. The SQLBrite will emit events to all the downstream consumers. So how do you make use of that? You just add this line to your build.gradle, and on your code, you just create an instance of this SQLBrite. The builder provides you a helper, a logger, and you can use it to maybe collect everything that happens on your crash reporting tool, or just at least see what's happening on Logcat. Another thing that it allows you to give is a transformer. And if you're familiar with RxJava, transformer, it is an operator that converts the whole string. So you can potentially do many things. Well, you'll see that the SQLBrite will ask you a scheduler, so you don't have to give a subscribe on here, but you can do other things. For example, Jake Wharton has a library called RxReplayShare, and what it does is cache the data or the value that's being emitted as long as there's one more subscriber. So this can be potentially super powerful. There's a lot of use cases that you can think about that. I'm just going to leave it here. It's a bit advanced. And then you create an instance of the Brite database, and you pass your open helper, and then the scheduler. And I just want to point out that the scheduler here is very important, because you see, when you get writable database on your open helper, if you have a non-migrated database, or if you actually Android, if it's the first time and you didn't really create your table, when you get the writable database, what Android is going to do is create everything for you. It's going to do the migration exactly when you do this operation, get writable database. And when you pass here the schedule, it's going to do so in a background thread, so you don't have to worry about this anymore. Yeah. This is how it looks like when you do a, so then after you pass this Boolean flag to make the login enable, you can pass your buildconfig.debug there, for example. And this is how it looks like when you try to wrap a content resolver. Very similar APIs. This is very interesting because you can wrap a content provider, it means that you can wrap other apps' database. And let's say you do that for the context, and you have an app that monitors context, or you provide a better implementation of a context. Everything that changes in that database, you'll get exactly notified on your own app. or anything like this. You can read what is happening on the Android system. You can wrap everything, and whatever happens there, you're going to get updates on your app. This is what SQLBrite provides you as logging. So here, for example, I have an example of me querying a book. It's going to exactly print what the query is and what the arguments are passing by, and one insert. For a strange reason, I guess it's a bug. It doesn't really print the arguments here, so yeah. OK, so then that's basically everything that I have for SQLBrite. How do you make use of that? Well, you make use of this Brite database that's provided now. And it's exactly the same as raw query, but it has this first parameter that asks for the table name that you're monitoring. And everything else is the same. So what it's going to do after you subscribe? Well, it will be retrieved a query observable. And when you subscribe, it's going to give you this query that you can run and then get the cursor. So as long as you remain subscribed to it, every change on that table will trigger you emissions. And then with the cursor, you can parse your data. So for every insert, every delete, update methods, they're all methods provided by Brite database. All of them will trigger notifications. So I have some examples here of creating, deleting, or updating. You have to, just want to reinforce it. You have to go through this Brite database. Otherwise, SQLBrite is not going to be able to monitor what's happening and won't notify you. Transactions. So sometimes we have too many operations in our database, and sometimes that can be too much to your subscribers. So what you can use is a transaction, and you can wrap all your transaction code inside it. And once you mark successful, then finally the SQLBrite is going to emit you the items that changed. Again, does it work with Kotlin? Well, yes. Also, they provided extension methods that help you with that. And what you have to do together with your build.gradle, you have to add this import, SQLite/Kotlin. And then the Kotlin module is going to provide you those map to extension functions. So you probably remember that Xjava 2 does not allow you to emit nulls. So you can potentially use, for example, map to optional. You don't have to worry about this. So if you query something and it doesn't exist on table, it's going to give you an option of nothing. So you'll still be notified, but there will be nothing there. That being said, I think let's go through and see how they work together, actually. One example, again, let's go to the book table. And I have 4 fields, and I have a select method. I have an insert. And let's keep those in mind. I'm going to go through an example of each one of them. On my Java class, I have, again, implemented the model that was generated to me by SQLDelight. I get a reference for the factory, and using the factory, I get a reference for the mapper. That's all I need. You can see here that I defined the published at field on my table. That's the type zoned datetime. So together with the constructor, I also provide an implementation of this map, this adapter that goes back and forth from the marshalling and the marshalling the value. So I also provided the implementation there. And so for the consumer part, this is how I would get a book published by a specific date. I'll use the SQLDelight part, getting, again, the factory. And now I'm not selecting all. I just pass a specific argument. And it's going to bind to the precompiled, or in this case, but you're going to pass this field, and it's going to give you this SQLDelight statement. And then on the SQLBrite part, well, one field that I didn't mention before, but also the query object contains is this tables. So you don't have to, again, type anything here. Like all the tables that are modified by this query is going to be there. So let's say you're doing a join. All the tables that are affected by that is going to be on this string array. And then you can use this helper, for example, map to one, which is basically a map and then a single. And then you pass the implementation of that map. And with just 4 lines of code or 2, depending, you will get potentially a book that whenever there is a change in that, you'll be notified on your UI. I just want to emphasize how clean and nice this is, because everything that we saw as pain point on the traditional Android APIs it's all gone. So I just want to take an example as to what I did before. This is how it would look like if I was using the traditional node APIs. And seriously, no one wants to do this. Seriously. Yeah. Another example that I mentioned is the insert. And so let's go through an example here. I have my repository, and I create an instance of this insert. Since it's precompiled and I can use it, I can save it as a private final. And every time I done an insert, I just bind the arguments that's given by the model. And then I just execute the insert. And this database operation is being worked on the Brite database, so it's going to notify the subscribers if there are. And also, it's going to return you some integer that represents the number of columns, number of rows that was modified. So you can, I'm emitting here just because of simplicity, but you can also get the value of that and analyze if everything was good or bad. I just want to also point out that both libraries, they're highly optimized. I think it's no secret for anyone that Square people highly value methods counts, and both combined generates just about 160. And plus the code that you generate. So you can see that's a very powerful combination, very, very efficient. That's everything that I had to say for both libraries. I just want to mention Room a little bit briefly. So Room, for those of you that was not on Florina's talk yesterday, it was released on Google I/O this year. It's part of the architecture components, and it aims to, it has the same goal as SQLDelight and SQLBrite, which is they avoid boilerplate code. They have compile time check SQL queries, and they allows you to do asynchronous queries. So more information, unfortunately. You have to see Florina's talk, but unfortunately it was yesterday, so you have to wait until the videos are online. So let's go through a quick review of what we learned today. So with SQLDelight, it allows you to, it gives you type-safe marshalling and the marshalling operations. It also compiles, it validates at compile time your statements. It auto-completes your queries. It incentivizes you to use immutable objects. And it doesn't hide any feature from SQL. Everything, all the feature sets, it's at your disposal. Just want to also emphasize the process, the migration process is not optimal, but hopefully we'll get better soon. For the SQLBrite part, it gives you support for also content providers besides the SQL Open Helper. It gives you real-time user interface updates. And one thing that I didn't really mention, but I would like to now, is that it's agnostic to your object mapper. So if you're using, let's say, cupboard, you can still wrap in SQLBrite and still get notified of that. So it's very simple, very agnostic. And with that, I'm happy to take some of your questions. Thank you.
Yeah, one thing I like was looking at SQLDelight is the fact that that they have created the .sq files, and one potential I saw for that was using this cross-platform. Do you know if there's been any discussion about generating Objective-C or Swift code with that?
There is no mentions for it. It could potentially do, but I don't think it's there on their short roadmap.
If you were working with a content resolver, my only experience with those is returning data that is on the device, like a contact, for example. Yes. So how would you create an object that would be emitted by the content resolver for SQLBrite? That's
the tricky part. Then, okay, because you don't know exactly how it is, you have to go through this cursor. At least, as far as I know, because